ASTC, Algebra 2 Trigonometry Regions. ASTC is the abbreviation of All Students Take Calculus. And that's really just an acronym to help us remember um, something. But let me explain what that something is. Basically, what we're talking about is we know we have four quadrants. We have, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And we've worked with our four quadrants now for a couple of videos. And so this information is not new. Quadrant 1 is between 0 and 90 degrees. And x and y are both positive here, right? Here's 0, here's 90. Quadrant 2 is between 90 and 180. And in quadrant 2, you have negative x values and positive y values over in this quadrant, like negative 3, 4, right? In quadrant 3, it's between 180 and 270, and you have negative x's and negative y's. So it's negative x, negative y. And in quadrant 4, the final quadrant between 270 and 360, you have a positive x value but a negative y value, like 3, negative 4, stuff like that. What is new, what we're adding to this, is this information here. And let me first draw some triangles. Let's talk about these quadrants one at a time. So if I draw a triangle in this quadrant here, we know that's what our quadrant 1 triangles look like. The angle, the hypotenuse extends out from the origin, and then we draw a vertical line back to the x-axis, and angle theta is always placed at the origin. So we also know that this is our x value, and it's a positive x value here. And this is our y value. It's a positive y value. Like if I gave you the coordinates, in this case it'd be 4, 4, but let's pick different numbers like 2, 5. 2 would go here, 5 would go here. We would do a little Pythagorean theorem to find our hypotenuse, which we use the letter r for, and that is always positive, right? Our hypotenuse always is a positive number when we do the Pythagorean theorem to get it. So what we notice is that in quadrant 1, when we draw our triangles, all three of these numbers are positive. And so what that means is no matter what ratio we do, they're all positive here. Like if we do sine of this angle, it's a positive y over positive r. It's a positive fraction. If we do cosine, positive x over positive r, it's positive. Tangent, positive y over positive x. And then, of course, the reciprocals would also be positive because they are just upside down, but they're still the same signs. And so what we say in quadrant 1 is we say all functions are positive. And we put a capital A in quadrant 1 to help us remember that all functions are positive. Let me draw another triangle. This time let's draw it in quadrant 2. And try to draw it about the same size as this one, but this one's in quadrant 2. Again, we know angle comes from the origin, hypotenuse extends out, and then a vertical line back to the x-axis. But this time, the x value would be negative, because in quadrant 2 we have a negative x, and a positive y value, and of course a positive hypotenuse r value. But what we see is the fact that x is negative here, that means that not all functions are positive. So our sine would be positive y over positive r, and sine is positive, but cosine and tangent actually are both negative. Cosine is adjacent over hypotenuse, and that's a negative over positive. That's going to be negative. And tangent, opposite over adjacent, positive over negative, is also going to end up being negative. So we put a big S in quadrant 2 to tell us that sine is the only function of the basic three, sine, cosine, tangent. Sine is the only one that's positive here because sine is the only one that's using the two positive lengths. Anything that uses adjacent, which cosine and tangent do, is going to end up being negative in quadrant 2. So quadrant 2 we often say is sine's quadrant because sine is positive there where cosine and tangent are not. And that's what this is saying over here. This first one in quadrant 1 was saying that sine and cosine and tangent are all greater than 0. They're all positive in quadrant 1. But in quadrant 2, you get sine is greater than 0, sine's positive, but cosine and tangent are negative. They are less than 0. All right, quadrant 3, you could probably see what's kind of happening here, but let me continue this. In quadrant 3, you just read this time, We know that we have negative x's, which uses the same thing here, and then we also have negative y values. But we still have a positive hypotenuse value, positive r. So we have negative x, negative y, but hypotenuse is positive. So what happens in this quadrant, with angle theta at the origin, with our opposite and our adjacent both being negative, sine and tangent are both negative. Sine and cosine, I'm sorry, are both negative. Because sine would be negative y over r, negative over positive. And you know, if they're both, if one is negative and one is positive, a division of a positive and a negative is negative, and that's what a fraction is. And cosine, negative x over r, again, negative, because one of each. But tangent is positive in this quadrant. Tangent's positive because that would be negative y over negative x. And a negative divided by a negative is positive. So quadrant 3 is tangent's positive. And then lastly, in quadrant 4, what we have is a positive x, but a negative y, and a positive r, of course. And so sine of angle theta is negative y over r, and that's negative. But cosine is a positive x over a positive r, and so cosine is positive in quadrant 4. And tangent's negative because it's a negative opposite and a positive adjacent. So one of each is negative. So what we end up with is this pattern where we say A for all positive in 1, S for sine is only positive in 2, T for tangent's the only one in positive in 3, and C for cosine's the only one in positive in quadrant 4. ASTC, and the way we remember ASTC is all students take calculus. It's just how we remember the order of which it goes. But these triangles should kind of make sense on why this is the case. Now, we're not mentioning secant, cosecant, cotangent here. We will be talking about them, but just remember that they are the sign of their reciprocals. So in quadrant 2, where sine's positive, that means that cosecant is also positive. You know, in quadrant 4, tangent's negative. That means cotangent's also negative. Cosine's positive, so secant's positive. So, you know, ASTC just talks about the 3 basic because we know the reciprocals are what their reciprocals are. All right, the way these questions typically work out is I give you some information and I want to know what quadrant are we in. So the way to do these problems best is to just draw a little sketch and label it ASTC. All students take calculus. If you want to make up a different sentence to remember that, go right ahead. But all are positive in 1. Sine's positive in 2, along with cosecant. Tangent's positive in 3. And what we mean by tangent positive in 3 is that sine and cosine are not. They are negative in 3. Cosine's positive in 4. Sine and tangent are negative. So here's your information. Cosine greater than 0 means cosine positive. So what quadrants are cosine positive? Well, it's positive where they're all positive, and it's positive in quadrant 4. This information alone is not enough to tell me what quadrant I'm in, because each function is positive in 2 quadrants and it's negative in 2 quadrants. So there's no way to narrow it down. But we do know that we are in one of these 2 quadrants. So then the second piece of information is cosecant less than 0. Now cosecant less than 0 is the reciprocal of sine. And where cosecant is negative, sine is also negative. So if you're given a reciprocal function in these questions, you can just think about it as the basic reciprocal of it. You know, because where cosecant's less than 0, sine's less than 0. The fraction's upside down, but the sign is consistent. So I'm looking for where is sine negative. Well, it's not negative in here. It's positive there. It's positive here. I'm looking for sine negative. Sine's negative here and here. Because I get my double check in quadrant 4, that's the answer. So quadrant 4 has a positive cosine and a negative sine and cosecant. One more example for you. Then draw yourself a little sketch, ASTC. Once you get this down, it's actually one of the easier things we do in trig, I think. So this one's not saying sine less than 0 or greater than 0, but it's showing me sine's negative. So where is sine negative? Sine is negative here and here. It's positive where they're all positive, and it's positive at the sign. So remember, S doesn't stand for wherever you see sign, you're there. No, it means sign's positive here. So if it's telling me sign's negative, then I'm not at the S quadrant. I'm at the spots where sign is negative. It's negative here and it's negative here. So then where is cosine greater than 0? Where is cosine positive greater than 0? The numbers greater than 0 are positive, right? So where's cosine positive? It's positive where they're all positive, and it's positive in its own quadrant where we put the C. So once again, my answer here is quadrant 4. And that's basically how we do these problems. We draw these little sketches and narrow it down to what quadrant makes the most sense. Okay, that's where we're going to stop it today.